Hello friends, this is Subhash Jadhav. I welcome you all in our lecture series for Assistant Motor Vehicle Inspector Examination, in which we discuss about probable objective type multiple choice questions. In today's lecture, we will be discussing about engine cycles. So let us start. The first question is, the mean effective pressure obtained from engine indicator indicates the mean effective pressure indicates what? So it indicates maximum pressure developed, it indicates minimum pressure, it indicates instantaneous pressure at any instant, or average pressure. So what is the probable answer? So let us see. So in order to understand this, we need to understand what is mean effective pressure and what is this indicator means. So basically what happens is, when we try to measure the pressure in the cylinder, it is difficult because the pressure inside the cylinder is different at different times, because as the compression is happening or as the expansion is happening, the pressure goes on changing. So it is very difficult to find out the pressure. So what we need to find out then, probably we will be able to find out some average pressure. And how to find it? So what we do is, we know that W, the work done, is equal to P into V, PV work. So here the P indicates the mean effective pressure and V indicates the volume, swept volume. This particular product is what we denote as the network. And what we do is we put a sensor, and correspondingly whatever work we get is being denoted by this particular area of this particular loop, and corresponding to this particular area, equal to that particular area, we draw a rectangle, and the rectangle, one side of the rectangle corresponds to the stroke of the piston. So this stroke of the piston remains the same, and corresponding to whatever the area is, we get this particular side. So if this particular side is longer, then we say the mean effective pressure is larger, and if this particular side is smaller, then the mean effective pressure is smaller. So here the mean effective pressure area indicates what is the work produced by the engine. So that is where generally the mean effective pressure is considered as a true indicator of the work output of an engine, because if it is increasing, we can clearly see that the work is going to increase, and whenever it decreases, the net work is going to decrease. So the mean effective pressure obtained from the engine indicator indicates average pressure. So this is the average pressure. So it indicates the average pressure. It is not the maximum or minimum pressure, neither it is instantaneous pressure. So it indicates the average pressure. So this is a mean. Obviously mean means average. So it is a mean effective pressure inside the cylinder. Next question is, the mean effective pressure of an Otto cycle increases with an increase in what? So options are pressure ratio, compression ratio, temperature ratio, and none of the above. So let us see what the mean effective pressure is, and then we'll. So mean effective pressure, as we have seen in the last slide, that it is PV work gives the network. So mean effective pressure is equal to network divided by the V, that is change in volume. So mass flow rate of working fluid, here it is written. So, or we can say the mean effective pressure P is equal to W divided by V1 minus V2, where V1 indicates the cylinder volume and V2 indicates the clearance volume. Now here pressure ratio. Pressure ratio basically is the ratio of the higher pressure to lower pressure, and the compression ratio here indicates the V1 divided by V2, that is cylinder volume divided by clearance volume, or initial volume divided by final volume, is your compression ratio. And the temperature ratio indicates the maximum temperature and minimum temperatures. So that is how we have here the compression ratio. So in the compression ratio, we have this, it is a ratio of cylinder volume divided by clearance volume. Cylinder volume corresponds to V1 and the clearance volume corresponds to V2. Now, this, when it is increased, that is when compression ratio increases, what it means, this ratio is going to increase, and when this particular ratio increases, in order to increase this particular ratio, the numerator has to be larger or denominator has to be smaller. That cylinder volume has to increase or so now that means 1.1 has to move toward this side, or the 2 point has to move toward this side, and it has to become smaller. So in this case, we say the compression ratio is going to increase, and when this increases, what happens? The area inside the loop is going to increase. That means net work is going to increase. In other words, the mean effective pressure is going to increase. So the mean effective pressure of a water cycle increases with increase in the compression ratio. This is the correct answer, because whenever the compression ratio increases, the net work output inside this particular loop is going to increase, and that results in the increase in the mean effective pressure. So the correct answer is B. This next question is, dissociation can be considered as. So and the options are disintegration of the combustion products at high temperature, reverse process of combustion, heat absorption process, and all of the above. Now, in order to understand this, let us understand first what is combustion. So combustion is burning the fuel, hydrocarbon fuel, with oxygen from the air to get this particular products. And what are the products? C from the hydrocarbon reacts with oxygen, combines with oxygen to form CO2, and H combines with oxygen to form H2O. That is, carbon dioxide and water are the products of combustion. And in engine, due to higher temperature, in the presence of higher temperature, what happens? This particular CO2 is going to disintegrate. So the disintegration of the CO2 into CO and O2, or disintegration of H2O into H2 and O2 at high temperature, and preferably this particular disintegration, that the molecule of CO2 molecule is going to absorb the heat to disintegrate this. Similarly, this also is going to absorb the heat. That is, at in the presence of high temperature and absorbing the heat, this particular products of combustion are going to disintegrate, and this particular process is called as dissociation. So dissociation is the disintegration of the combustion products at high temperature. This is the correct answer. Similarly, here the combustion produces heat and this absorbs the heat. Obviously, this becomes reverse the combustion, so it is a reverse to combustion. It is obviously a heat absorption process, because here it is an endothermic reaction. It is absorbing the heat, so it is a heat absorbing process, and therefore all three A, B, C all are correct answers. So last one is the answer for this question. Now the next question is, with dissociation of the exhaust gas temperature, what happens? Gas temperature decreases, increases, or no effect is there, or increase up to certain air fuel ratio and then decrease. These are the options. Now, as we discussed earlier, the fuel and oxygen combines to form this particular products, and this particular products, when disintegrate by absorbing the heat. So these are the endothermic reactions, and they absorb the heat to disintegrate, and this is what we call as dissociation. Obviously, since they are absorbing the heat, the net temperature of the content inside the combustion chamber is going to decrease. So the correct answer is A, that is, it is going to decrease. There is no probability of increasing or no effect, or any other probabilities are not there. So the answer is A. Now next question is, with the dissociation, peak temperature is obtained when? At stoichiometric air fuel ratio, when mixture is slightly lean, when the mixture is slightly rich, or none of the above. These are the options. So from this particular graph, we can clearly see that if this particular dark line indicates the temperature, change in temperature with air fuel ratio, change in air fuel ratio, while the dotted line indicates with no dissociation, and this indicates with dissociation. Now if there was no dissociation at all, the temperature might have become maximum when it is stoichiometric. That is, if the mixture was stoichiometric, then in that particular case and no dissociation is happening, then a maximum temperature might have attained in case of stoichiometric. But in case of with dissociation, that is when the dissociation is happening, and we know that dissociation, due to dissociation, for dissociation the temperature is being absorbed, and the net result is that the maximum temperature is happening on the rich side, that is here. So on the rich side we are going to get the maximum temperature as indicated by this particular curve. So the correct answer is when the dissociation, with dissociation the peak temperature is obtained when the mixture is slightly rich.